We are back to the 24th problem. Now, here we need to solve real world problems of indefinite integrals. Before we begin, I want to tell you about few things, that is acceleration, velocity, position. It is very important for you to know integral of acceleration is velocity, whereas integral of velocity is position. Now, in this particular problems, you will either be given acceleration or velocity. You need to solve for position function. Let us directly start solving this because this is an easy problem given as the function, velocity function, and then you have got the initial position. But you need to find the position function with respect to t. That is s of t. You will come to know in a while how easy it is, but before that, remember integration of what is what. Now, integration of velocity is position. So all I need to do is integrate this v of t. That will be equal to what? Integration of v of t? 3t minus 12t square by 2 plus c. I have done integration. 3 nothing is there, so it's t minus 12t square by 2 plus c. Don't forget the c is very important. Now I'll just simplify this and write it'll be 3t minus 6, sorry, not 12, minus 6t square plus c, and this is basically the position function s of t. Now this is a crucial thing to remember over here. The position s of 0 is given. That means if I have s of 0, what will happen with the t values? It will be 0. So this becomes 0 minus 6. This becomes also 0 square plus c. What is that equal to? It is equal to 3. See, they have told the position when all this function is where t is 0 means the 0th time at the initial point where time is just starting 0 time, the initial position that means is 3 meters. So put the function over here, everything wherever t is there, put 0 and solve for the constant. Now, since it's a polynomial function over here, just t, right? Whenever you multiply, it will just become 0. Sorry, over here, see it, when you put 0 it will just become 0. So whatever is this value remains, that is c is equal to 3. So the final answer is this, but instead of c you write 3. Let us see over here. This is the answer. How do we do? Integral of velocity, that gives you this answer, 3t minus 6t square plus c. Then what you have to do is substitute the initial position, that is t as 0, and solve for c, because we know the final answer would be 3, and then we get c is equal to 3, and this is the final answer. Similarly, we have one more problem where acceleration is given. Now it is the same thing. I'll just solve it very quickly over here. But over here sign is there. So remember, be careful when you substitute these initial points. Now integral of acceleration will be equal to 3 cos. See, now I forgot the minus sign, will be minus cos, okay? Sine integral is minus cos t plus t equal plus c, sorry. This is the thing. Now this integral a of t means it is v of t, okay? V of t. Now let me put this t as 0, and wherever there is t, I have to put 0 plus c equals, what is the initial velocity? It's 0. But now look over here. What is cos 0? Put your you can try it in your calculator. If you know the graph of cos, see, sine starts from 0 0, but cos starts from 1. So the value of cos 0 is 1. So minus 3 into 1 plus c is equal to 0. Take this to the other side, c is equal to plus 3. This is the answer for velocity. Now this is the equation, minus 3 cos t plus 3 is the answer. Let us see the written over here. See what happens? Minus 3 cos t plus 3. So this is the velocity position. Now we did just now in the last problem from velocity to position. Same thing will be repeated now from velocity you can find the position by integrating the velocity. It'll be minus 3 integral of cos t. Integration of cos t is just sine t. So minus 3 will remain, sine t over here t squared by 2, 3t plus c. Now again you need to put everywhere wherever t is there 0. See now sine t, sine 0 is 0, this is 0, this is 0. So c value will be equal to 4. So the final answer over here will be minus 3 sine t plus t squared by 2 plus 3t plus 4. That is it. That is the position function. Now that is straightforward. Please make sure you solve the remaining problem by yourself. Very simple integrals, and that's it. And then check with the answers over here. All the answers are solved. Now we will quickly go to the last problem, the 49th. There are two problems over here. This is interesting because they have told you sketch the graphs of two function, the function that is f of x. We must graph the function, but they have given us the derivative. See now this is a derivative, that is f dash function. We need to find the normal function. So now imagine you have been told the derivative f dash of x is x cubed. This is the function. It's x cubic graph, right? And it's up by 2, so I'll write plus 2. Now, how do you find the function? Integrate it. Integrate f dash of x. You will get f of x. Isn't it? The function will be obtained. Now, integration of this would be x to the power 3 plus 1 is 4 by 4 plus 2x plus c. We don't mind the constant. It can be anything. It's fine. So this part is important. Now, it is very hard for me to graph x to the power 4 plus 2x. How would you graph it? You know, this also, see, I don't know, there might be anything. This c can be 1, 2, 3, anything. It can be, see the graph, whatever I draw, if it's x to the power 4, it might be like this, or it might go up like this, something like this, or like this. It can be anywhere. The vertical shift, I mean, up, going up or down, even it can go down like this, anywhere up or down. So what it means is I won't be able to draw the exact graph, but I will be able to tell you how does it look. Now, how does it look? This is the derivative, isn't it? F dash of x. So remember in the first chapter, in the initial lessons, the video number 1, 2, 3 and all, initially, we were finding the critical values. That is, the derivative f dash of x was made equal to 0. And then we found the critical values. Why? Because at the critical values, there was maximum or minimum values, isn't it? Maximum or minimum. So over here, now you don't have this graph. Try to ignore this graph. Think it's not there. So this is somewhere at 2.4, isn't it? So at 2.4, over here, critical value will be there. So I will have either a minimum point or a maximum point. I don't know the graph. That's why I'm just assuming it will be up or down over here, okay? But how would I know it's a maximum or minimum? It's simple. You can see there's only one critical point, isn't it? So there is only one over here in the answer, minimum. It won't be 2. So you must know there is only one critical point at minus 2.4. Okay. Now, we used to do that, like this. We used to take the critical point, say 3, minus 3 or 0, and then we used to find whether it's positive or negative value. In f dash, if it is negative value, that means it's decreasing. So now look over here, critical value is obtained. This is either minimum or maximum because I don't know the graph, right? How will I know? How will I know which is maximum, minimum? It's very simple. See if the graph below this intercept over here is below the x-axis or above the x-axis. It is below. If it is below the x-axis, then what? If it is below the x-axis, then the function will be decreasing over there till that. So what you have to do is an exam, you will have like this, right? At negative 2.4, you must draw somewhere any, you won't know the exact value, but somewhere over here and just draw because it's the minimum, right? Don't do it up over here. If you do it up, then everything will be shifted upwards. You can do it because anywhere it's correct, it will be vertical shift. It's your graph will not be same like the others graphs. Okay. Now what you need to do is, all you need to do is make decreasing. So this is decreasing, okay? Next, look at the right side. Is it increasing? Is it positive values? Yes, it is positive values, isn't it? So then what I do is I just do increasing. But this is not correct. Why? Because in this particular case, there is no other values, but just make sure over here, it is passing through y-axis, and this is not a quadratic. It is not quadratic to be curved. Look, this is cubic, right? That means this is x to the power 4. So draw this point, and then wherever the f dash of x is 0 over here, this passes through the center, this point over here, okay? Then you can just like have some inclinations like this. See, it's like just some, modulation. That's it. Not the exact one. This is the approximate graph, because since it is if you wait, I'll just tell you why you should not do like this. This means it's parabola x to the power 2. Look, the derivative is x to the power 3. That means the function must be x to the power 4. So really x to the power 4 graphs will be something like this. So that is why you draw it, and it's approximate. Just tell that this is a cubic graph. This will be around x to the power 4 graph, and then below this point everything is decreasing. Over here it is increasing. That's it. That is the main things you can do, and this is approximate graph. There is no correct answer. There are many correct answers. That's the thing. Okay. um, and over here, see, now one more thing. Look, if you see, there is all these dips and all. This is just for extra thing. Now wherever there is change in this angle, see, there is the inclinations. So what I'm trying to say is, you can see over here there is concaving down, concaving up. So those all things can be done in detail, which we have done in the previous lessons. So that and all is there, but basic graph is fine. So that is the thing. Over here it's the same thing. Now you have been given the derivative. So derivative is given. What is the function then? Now over here, see, this is a constant, right? This is a constant. That means there was a straight linear graph somewhere, all these points. See, at this point it is linear, and this point also it's a linear. Now since it's a step, it is going up. Then over here it is parabola. So over here it is like this, and then over here this is a not a, this is a straight line, and from this point again it's a straight line. Why? It's linear. So just understand that these are all the functions. If you integrate this, what will you get? Now over here you will get cubic, right? If you integrate this, you will get cube. This is a constant number 1. When you integrate this, you'll just get x. So this is the one. And look over here, there is no values below over here. So ultimately this is just increasing. See, it's going upwards. See, there is no critical values over here. So you can match these. So this is the graphing part. It can be, many graphs can be the same answer, but this is very important because that is the objective we mentioned about, indefinite integrals. So be thorough with this, and graphing is pretty easy because many graphs can be the same answers.